name is Daffy and this is my partner Jen.
So for today, we're gonna solve a venturimeter problem with a manometer attached at the inlet and the throat. So this is our sample problem. The venturimeter has a vertical orientation with a manometer containing glycerin at a deflection of E equals 650 mm.
And we are going to show you the steps and the process in solving this problem.
In this problem, we are tasked to solve for A. Pressure difference between the inlet and throat. B. Determine the theoretical discharge. C. Determine the velocity of the throat. And D. To determine the coefficient of discharge if 285 liters was collected at 4 seconds. So in computing the pressure difference, we'll be using Bernoulli's equation from inlet to throat. Knowing that Z sub 1 is equal to 0, we're going to transpose all pressure heads on the left side while velocity heads on the right, leaving us with the equation P sub 1 minus P sub 2 divided by unit weight equals V sub 2 squared minus V sub 1 squared over 2G plus Z sub 2. To solve for the pressure difference, we'll be summing up pressure heads from the throat to inlet using the manometer tubes by adding pressure heads going down while subtracting when going up. We obtain the equation P sub 2 over unit weight plus 0.750 minus 0.650 minus y plus 0.650 times 1.26 over 1.03 minus y equals P sub 1 over unit weight. Transposing P sub 2 over unit weight to the right side, we can compute for the difference of pressure, which is equal to 0.895 meters. After solving for the pressure difference, we can proceed to computing for the theoretical discharge using Bernoulli's equation. First, compute for the cross-section area at both points. Since the diameter of both the inlet and throat are given, simply solve for the area using equation A equals pi times d squared over 4. Once we get the areas of both points, substitute the values in the Bernoulli's equation and solve for the discharge Q. We will obtain a value for Q which is equal to 0.0304. Next is to solve for the velocity of the inlet. For this case, use the same Bernoulli's equation, but this time substituting V sub 1 with Q over A, leaving us with V sub 2 as the unknown variable. Simplifying the Bernoulli's equation, we will compute V sub 2, which is equal to 1.69 meter per second. For calculating the coefficient of discharge, first we need the value of QA and QT. Given that we have 285 liters of water was collected in 4 seconds, we could solve the actual discharge by dividing them. First, you need to convert liters into meters cubed simply by dividing it with 1000. Next, divide the volume collected 0.185 meter cube with the time 4 seconds to obtain the actual discharge, giving us a value of 0.07125 meter cube per second, after which we can obtain the coefficient of discharge simply by dividing the actual discharge with the theoretical discharge, which we have to compute earlier. So this will give us a value for CD which is equal to 2.34. Now, do take note that the CD value should not be more than 1. So therefore, there must be something wrong with the given in the problem. But anyways, these are the steps in how to solve a venturimeter problem with a manometer tube.
So these are the steps in solving the venturimeter problem. I hope that you've learned something out of this video.
So Thank you for listening and see you next time.